Hi, Anthony Carruthers, Better Lesson Master Teacher Project. And here we are showing that the midpoint of the hypotenuse is equidistant from the vertices of the triangle. So I start this demonstration for students with a right triangle like the one you see here. And we'll go ahead and construct the midpoint of the hypotenuse. All right, and let's call that point, we'll leave it up to Sketchpad to name the point. Okay, it'll be E. All right, and then from there, I basically want to show that E is equidistant from B, C, and A. E being the midpoint of the hypotenuse, we already know that BE and EC are equal to each other. So I can go ahead and put those tick marks there. So what we really need to show is that the distance from A to E is the same as that distance from B to E and from E to C. So to do that, I'm actually going to compose a rectangle from this right triangle. And to do that, I'm going to make use of a translation. So I'm going to mark the length from A to B as a vector. And what I'm going to do is take segment AC and point C as well and translate those along that vector. Okay, that will ensure that I have a nice rectangle. Okay, so from there all I need to do is connect this new point down to C, and I will make this a dotted segment also so that we know that this is something that we added. Okay. So being that BC prime CA is a rectangle, we know that the diagonals of a rectangle must be congruent. So if I were to draw diagonals, or diagonal AC, we know that AC is congruent to BC. And since rectangles are also parallelograms, I also know that the diagonals will bisect each other. So that tells me that CE is equal to AE. All right. So we could definitely reason down to the fact that CE, AE, BE, and EC would all have to be equal to each other. So at this point, we've shown by using a rectangle and the properties of parallelograms that E is actually equidistant from B, C, and A in the original right triangle. Anthony Carruthers, Better Lesson, Master Teacher Project.